This week, the team behind one of the most impressive open source models, the model that frankly I use for all of my projects, Qwen, had a big little shakeup when one of the lead researchers who built Qwen, Yunyuan Lin, I hope I'm pronouncing that correctly, decided or posted on X that he was leaving. Now it's actually unclear whether or not he's actually left.
Oh, interesting.
But on X he said, "I'm stepping down by my beloved Qwen."
Beloved Qwen.
And I actually read that initially as "by my beloved queen."
Yeah, I know. I hear you.
Which maybe is what he meant. I don't
also,
know.
maybe inspired Qwen originally.
Oh, Qwen and Queen?
Queen?
Maybe. I don't know. Yeah. Very, very unclear, who's actually working on these models. There's a little less oversight over these Chinese models than there is for the American models. But we know that Yunyuan Ling is one of the lead researchers and that he is presumably leaving Alibaba's team. And that's pretty much it. And then as a result of this tweet, within hours, we know that a couple of more senior researchers actually have also left. So this kind of reminds me a little bit of the shakeup in thinking machines where you had one person leave and then like a bunch of other folk also follow.
Yeah.
So Binyuan Hui left, Bowen Yu left, Kaixing Li. These are folks who led teams like Qwen Decoder, who led the post-training process, and also the Qwen Vision language model. Apparently, it seems that this might have been due to a reorg within the company that saw some folks from Google come in and actually take charge of the division, but that's a little bit TBD.
Mm-hmm.
Also, it seems like the timing here is particularly painful. Do you want to explain why that might be?
Yeah, I mean, this coincides kind of with the launch of Qwen 3.5, which everyone's been talking about. It comes in all these different size varietals, including, I think the biggest one's maybe 120 billion parameters, but it scales to really small sizes as well that you would be able to fit on a phone or on a laptop.
Yeah, exactly. I mean, Qwen 3.5 is strikingly good. I think everyone's been using it recently.
I think one of the tweets in the aftermath of this departure too was someone saying that without the leadership of this individual, they also would not have been able to compete toe-to-toe with the big frontier labs and produce a model nearly this good. Like that almost gets into the data conversation that we were just having of like, this seems to be like a team that was almost focused on doing more with less in terms of physical infrastructure and access to data. And somehow they were able to churn out this model.
That's kind of the through line with these Chinese
better
companies.
Better than Llama? As good as Llama?
Yeah. Well, I mean, one of the big realizations of the Chinese labs is that they can do really well with very little resources.
Yeah.
Like the fact that they have been embargoed from using the H200s has led them to innovate on efficiency, in ways that are really striking. So the timing here is absolutely crazy, especially given that these models just released like a couple of weeks ago. I guess like it's unclear where it stands right now. Like, is Lin actually coming back? It's a little unclear.
Yeah, I mean, I think it's interesting that this departure, both like the hiring in of this Gemini guy, allegedly, as well as the departure of Lin, coincided also with a drop of Qwen 3.5, which everyone's been saying is an absolutely rock solid model. It's a family of models, actually, technically. It has sizes from, I think, 0.8 billion all the way to like 122. So you can kind of choose your balance of how much precision do I want for like, how much efficiency do I want in this model? And I think that range itself makes it so exciting to people because it's this idea of, you can take a really powerful one, run it in cloud GPU, but you can also take a still good but very small model and run it on a phone with like almost near real-time latency requirements. So it's a diversity of model architectures that kind of let you choose whatever you want. Maybe it's worth us spending a little bit of time talking about what brings them together, like the common architecture choices that are happening in Qwen 3.5. and how they differed from either the other Chinese architectures or from like Qwen 3.
Yeah, it's a good question. It's unclear exactly what these models are doing. We know a couple of things. So Alibaba, who we should say, by the way, I mean, is obviously the company behind Qwen, they've been doing a ton of work on efficient architectures for these models. So when we talk about a transformer model, transformers are not built the same anymore. Modern day transformer models will have the normal attention mechanism that we're used to, but nowadays, typically people will add in additional layers, sort of like wedge them in between attention blocks that aren't attention. They're something completely different. And so these are typically known as linear attention blocks. This differentiates them from normal attention blocks, which are n squared. So they're quadratic attention blocks. The idea here being that this attention mechanism looks at all of the tokens in a sequence and does basically like a pairwise combination of these different tokens.
Mm-hmm.
It's expensive because you have to basically, for each token, compare how similar it is to all the other tokens in the sequence. And
Query value, baby.
And that really slows down the computation of these models. Linear attention is the idea that you can basically not do that. So rather than combining all of the input tokens with each other in some complex way, you can just look at the input stream in one go, in one quick pass.
Now, which is almost kind of what RNNs did.
That is exactly what RNNs did. They are the OG linear attention blocks. And so nowadays what we're trying to do is reproduce RNNs effectively in a transformer. This is basically faster. It lets us do things in a way that is computationally more effective. The issue is that these things don't have the ability to do associative recall very well. There's like this fundamental tension between linear attention and quadratic attention. Quadratic attention is really good at doing associative recall, but is slow. Linear attention is really fast, but is bad at associative recall. So what's associative recall? Basically, in a linear attention block, if I give you the input stream A, B, A, B, A, what do you think is the next thing I'm about to say?
B?
B. That's right. You did it, right?
Far too long.
A linear attention model would be really confused. A linear attention models have a hard time doing this really simple task, right? And typically it's not as simple as that. It's like you can test this out by going like A, B, C, A, B, A, B, C, A, B, right?
C.
Right, exactly.
Or for like copying and pasting code, this becomes really problematic.
And
you know what I mean?
Exactly.
Like,
so copy pasting is something that attention models are really good at doing. Attention models are really good at literally taking.
It's the first circuit these transformer networks learn.
Exactly. They can literally just copy paste easily. Linear attention just can't copy paste, almost as a fundamental problem of its architecture. Like it's built into the architecture that it can't copy paste. And so these Qwen models are good because they figured out a way to incorporate linear attention that still has the ability to basically do this copy pasting thing. Or at least they've innovated some mechanisms that let these things still be pretty good at copy pasting. And they do this using something called a delta net. In particular, a version of the delta net known as the gated delta net. So we can maybe get into this a tiny bit. The idea here is basically that these delta nets keep a running memory state. So whenever they're processing the input, they keep this like memory. And they can, at each time step, when they're processing the next token, decide whether they want to delete from the memory or write into the memory. And they can also gate, so basically decide how much they want to write in or delete from the memory state. It's basically, think of it as like a compressed representation of everything the model has seen so far that is being continuously rewritten in place. So they keep rewriting the same thing in place. And so this gated delta net is kind of like the thing you do if you want to find something that has a pretty good trade-off between associative recall and still being a linear model. It's really quick to run. And importantly here, the Qwen model isn't just using this linear attention model. As I was saying, it wedges it in between normal attention blocks. So it's kind of like finding this happy medium between something that is fully attention and something that is quick linear attention. Anyway, that's the big innovation here. Qwen is like a pretty good new architectural choice. And in practice, it ends up being pretty efficient. The interesting thing here is that they were able to scale this approach down to 0.8 billion parameters. 800 million parameters is so small. Dude.
Yeah, it's crazy.
It's so freaking small. That's insane.
Also known as 800 million parameters.
Yeah, exactly. It's so small. Like this is like the type of models we were working on in like 2000. You know, these are like tiny models comparatively to the ones we've seen recently.
Totally.
So it's really cool stuff. It is weird that this leadership change came in just as these models were released. What does that mean for the future of these models? Is there going to be a Qwen 4? Why did this even happen to begin with? These are completely unknown questions, but I really hope that a Qwen 4 model comes out because Qwen 3.5 is like the thing that everyone uses now whenever they want to like create a startup basically or experiment with some idea, right? It's like you take the Qwen 3.5 model and build off of that.
Yeah, Qwen's fantastic. Had a great data set. A good learning curriculum that they use for it. Good, I think, smart architecture choices to try to make these more efficient. Yeah, we'll see how much of the team stays. We'll also see if Lin stays.
So here's the interesting thing. As of, I think, yesterday at 2 p.m., Lin posted on his WeChat moments. So I think these are like kind of like
Snapchat stories?
Snapchat stories. He says, Brothers of Qwen continue as planned. No problem.
Interesting.
What does that mean?
What does that mean?
Who knows?
Are they branching? They doing a Frontier Lab? It's kind of what it sounds like.
Oh, is that what you thought?
It's the brothers, people that left with them. Maybe the brothers are leaving.
See, I would have read that as Brothers of Qwen continue. As in, like, I'm still with you guys. Like,
I see.
I haven't left.
Yeah,
We
yeah.
continue as planned. I don't know,
Interesting.
man. I don't know.
Well, we can speculate till the cows come home, but I'm sure
Maybe we should make
We'll
a
see.
poly market of this, dude.
Honestly,
is
not
Lin
it's a
staying?
really
Is
niche.
Is he going? Who
we'll see
knows?
what liquidity it ends up having.
We'll see.
Yeah, I hope there's Qwen 4. I hope Alibaba doesn't get cold feet about open sourcing these models. Like I feel like what we've seen with some of the other labs is that they'll open source a lot, like Mistral in the early days, and then they'll get a little bit more and more and more conservative about what they open source versus what they keep in the cloud, trying to recoup some of the investment costs, I assume. So yeah, we'll have to see. But I hope there's a Qwen 4 or someone picks up the mantle, maybe the same team, and they just end up doing some other research elsewhere.
Yeah, I don't know, man. I'm excited though. This is it's cool stuff.
Yeah, it's a good time in open source.
Yeah,
I actually feel like for the first time, I feel like we're starting to get really good small models and big models releasing open source.
Thanks to the Chinese companies, dude. That would not have been on my bingo card for 2026.
I think, same with me.
Yeah,
same with me.
Cool stuff.